All right, this first one, notice here we have two segments that are both inside the circle, two chords inside the circle, and they intersect at a point. And the theorem that we looked at, the first theorem that we looked at, says that the product of the two segments of one chord should equal the product of the two segments of the other chord. So we should say that 18x, that product of x and 18, should equal our 12 times 9. So in this case, 18x would equal 108. So then x would end up being 6. Okay, and it says again, because we have these two chords that intersect inside the circle, we were just to find the value of x, so we've done that. We could talk about chord lengths at that point in time too. For this next one, we're taking a look at two secant segments. So again, here we're trying to find HG, by the way, and so that one, since we don't know what HG is, let's call it X for right now. We know that the product of the whole secant segment and its external segment should equal the whole secant segment and its external segment of the other one. So in this case, we're taking the whole secant segment here would have been 21. So we're taking 21 times 11, the whole secant segment and its external segment. Now here the whole secant segment would be x plus 12. So we're going to take our x plus 12, that whole secant segment, times its external segment, which would have been just a 12. Now as you're simplifying this equation a little bit, we know 21 times 11 should be 231 is equal to, and as you distribute, we have a 12x plus 144. So if we subtract our 144, we'd end up with an 87 is equal to the 12x. And as you divide both sides by 12, x would be 7.25. Here they asked us to find HG. I wouldn't want to leave it as just x equals. I would want to say HG is equal to our 7.25. Our next example, notice here we have a secant segment and a tangent segment. And we're missing some parts, but it does go through the center, so because it goes through the center, we know that this whole thing is the diameter, this whole internal part, I could say, of that secant segment. Our goal is to find the radius. So we really just need to find what this one part of it is, but to talk about the whole secant segment, I'm going to call that 2r. That's our whole radius. The two radius together would make that whole diameter. So when I talk about the secant segment, the whole secant segment would be our 2r plus the 18. The product of that and its external segment, so times our 18, should equal, and now I've got just a tangent segment, so it's going to be that tangent segment squared, because again, I don't have an external part to talk about. That's the whole tangent segment. So 32 times 32, or 32 squared. Well, as you're working through this, you'd find that we'd get a 36r plus our 324 is equal to 1,024. So when you go ahead and subtract our 324 from both sides, 36r is equal to 700. So as you divide by 36, that radius would end up being, you could say, 19 4/9. You could have called it 175/9 if you simplify. You could have said 19.4 repeating, which is probably not the best answer since that's a rounded answer, and of course, you know, we love to leave our answers as exact as possible. All right, this next example, notice again we have a tangent segment and a secant segment. I'm supposed to find AC here, so I'm going to go ahead and call that part X for right now. And we know that the product of that whole secant segment and its external part, so I could say the product of the whole thing would be an x plus 12 when I put those together, and its external part, which is just an x, that product is equal to, for a tangent segment, we would say that quantity squared, so 8 squared. Now, notice on this one when we distribute, you're going to end up with a quadratic equation. We have an x squared plus a 12x is equal, and we know that 8 squared is our 64. With quadratic equations, we want to set them equal to 0 first. So I'm going to say x squared plus 12x minus 64 is equal to 0. If it's quadratic, you have lots of choices. You could solve by factoring, you could solve by completing the square, you could solve by the quadratic formula. For this one is factorable. I would probably go ahead and factor it. If it is factorable, that's usually the easiest choice. Factors of 64 would have ended up being 4 and 16, which would have given us our positive 12 as long as the 4 was negative. And because the leading coefficient is just a 1, we can use our shortcut to just say it. We have an x minus 4 is one of our factors, and the other factor would have been our x plus 16. And when you set each one of those equal to 0 then, you would have found that x could have been 4 and x could have been negative 16. Now, taking a look at this one, we're talking about a length of a segment, and we know that a length could never be negative, so this x equals negative 16, that's an extraneous solution. It's not true in the context of the problem we're solving for. So here x could only just be the 4. For this last example, again, here we've got two secant segments, so now we know we're looking at just their whole secant segment times its external part would equal the whole secant segment times its external part. So for this first one, I could say x plus 29 for the whole secant segment times just its external part, x, is equal to that product of the whole secant segment, which 35 plus our 15 is going to give us a total of 50, times just the external part, the 15. And as you distribute on this one, you would have had an x squared plus our 29x is equal to 750. Again, we've got a quadratic equation, so we want to set it equal to 0. So as you move your 750 over, x squared plus 29x minus 750 is equal to 0. Now this one's not so pretty because this one doesn't factor. So I'm going to go ahead and use quadratic formula just to see if we remember how to do that. The whole quadratic formula again was the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So for this problem, we could look at our a is that leading coefficient, that coefficient of x squared is 1. B is the coefficient of x, the 29, and c is our negative 750, that constant. Alright, so here we go. We're going to take the opposite of b. In this case would be a negative 29 plus or minus the square root of, we're going to take our b squared minus 4 times a times c all over 2 times a. And as you start simplifying, you would realize that you're going to end up with a negative 29 plus or minus the square root of 3,841 all over 2, which doesn't come out to be a nice pretty fraction. So this one's going to have to just be an approximate decimal. You would end up with x is approximately equal to either a 16.49 or, if you do the minus scenario, a negative 45.49. Obviously, again, we can't have a negative side length, so x is approximately 16.49.